Hello and welcome back. We're going to continue our discussion with the 2015 AP Calculus exam. We are now on question number 4. Now question number 4 is our differential equation. Now this was an interesting one when it came out. A lot of people had a hard time with it because if we look at the differential equation that they give us, 2x minus y, a lot of students thought they had to solve it. Now this is a very hard differential equation to actually solve. They don't want us to solve it, they just want us to be able to understand what it kind of means for us. So for the first question they're asking us is to sketch the slope field, and at 6 points. Now if it's not a point, don't sketch it. You can lose a point there. So if I start here at -1, 0, -1, and if I want to find the slope there, I just plug that into my slope field. This becomes 0 plus 1, so that's just 1 right there. If I plug in the point 1, -1, my slope here is going to be 2. What's that going to be? Plus 1, so that's going to be 3. So that's pretty steep. Remember, slope fields are that's my little slope right there. My next one is 0, 1. My slope here is going to be 0 minus 1, so that's just -1. You don't have to be so accurate on it, just when we kind of get a good approximation of them. No arrows, just little lines. And then my next one is at 1, 1, 1, 1. And this is going to become 2 minus 1, which is 1. And let's see here, the next one that we're going to give is 0, 2. Well, that's going to be a slope of just -2. A little bit steeper than that. Doesn't have to be perfect. There we go. And then the last one is at 1, 2. And that's going to give us a slope of 2 minus 2, which is 0. So that's a horizontal line right there. So let's talk about the points here. It didn't take us very long to do that. You get a point anywhere where x is 1s. These, you get a point for all of those, and you get a point for all of those. So you got 2 points just for that slope field right there. That's pretty cool. Alright, question number 2 is where the fun begins. Alright, it says, find the second derivative in terms of x and y. I'm not going to do anything else yet. I'm just going to find my second derivative. Be very careful when you take the second derivative. So we're taking, we're going to get, now we're going to get dy, d2, dx2 is going to equal, ready, my derivative. And with respect to x, this just becomes 2 minus the derivative of y is dy dx. Now I can simplify this a little bit because I know what dy dx is equal to. What is it equal to? It's at 2x minus y right there. So this becomes 2 minus 2x, distribute the minus, plus y. And there is our second derivative. Alright, now let's see what they say. Determine the concavity of all solutions for the given differential equation in quadrant 2. And then it says give a reason for your answer. Alright, so let's see here. In quadrant 2, well, in quadrant 2, here's what I know about the signs. In quadrant 2, all of my x's are negative. All of my y's are positive. So I can plug that in. Now, it's not going to equal 0, so 0 cannot be an option, so keep that in mind. So if I use that idea in here, I would say d2y dx2 is equal to 2 minus 2. Remember, all of my x's are negative, so this is always going to have a negative x value. My y's are always going to be positive, so that's going to be a positive y value. And if I simplify it, we get 2 plus 2x plus y. So if I think about this, there's no value for x and y in the second quadrant that will make this negative. That will make this 0 or negative because we're always adding a positive value. So this is always going to be greater than 0. So therefore, excuse me, therefore, all of our solutions, now this is concave, so this is positive. Remember, this is, so my second derivative is positive, will be concave up. Concave up. And that is because the second derivative is positive. Points. 1 point for your second derivative, 1 point for your answer with justification right there. Alright, so for part C, it asks, let y equal f of x. Now this is where people had a really hard time with this one. They kept thinking, oh no, we have to solve the differential. You don't have to. Let's take a look. Let y equal f of x be a particular solution for the equation, given the initial condition. So they give us this initial condition, 2, 3. Does f have a relative minimum or maximum or neither? You don't have to solve the function in order to do this. You just have to use your derivative test. So if I want to find the derivative, dy dx, see, if I want to do relative max or mins, remember, this is my first derivative test. I can just plug in the point at 2, 3. And if I go up here, if I plug in 2, 3 into here, into my original function, I'm going to get 2 times 2 minus 3, which is 1. Now this is really tricky. This does not equal 0. Therefore, 2, 3 is not even a critical number. So you want to check to see if this is a critical number first. It's not a critical number. Therefore, it can't be a maximum or a minimum. Remember, for a minimum value, you have to have a critical number. Same thing for a maximum. You have to have a critical number. So therefore, this is neither. Therefore, 2, 3 is neither. Oops, let me spell that better. Come on. There we go. It's going to be neither. Very good. All right, so how many points would this be worth? Well, you would get 1 point for plugging in the point here, and you get 1 point for your answer. Now, I do want to put a warning here. Most of you all were probably thinking, oh, I will use a second derivative test. And you can do that. If you plug it into your second derivative, this is a warning, you would get 2 minus 2 times 2 plus 3. So you would have got, don't need that, equals 2 minus 4 plus 3. You would have got 1. Now, this is greater than 0. So you would have been thinking, at 2, 3, it's concave up, so it would be a relative minimum. You would have got the wrong answer. So you always want to check your critical number first. So this would be wrong in this case. Now, if this were 0, then you would plug it back in into your second derivative. All right, part D, let's take a look here. This is a really good question right here. All right, it says, find the values of the constants m and b for which y equals mx plus b is a solution to the differential equation. Now, this is a tough question when you on the outside. So we want to find m and b so that this solution is a solution to our differential equation up here. So if it's a solution, one thing I can think of is the second derivative. If I just think in terms of the second derivative, I know that the second derivatives have to be the same. Must be equal. So if I take the second derivative of this, which is a line, so I know that the second derivative of my line is going to be 0. So y prime was m, y double prime is 0. So therefore, I know that the second derivative here is 0, but that also has to be equal to the second derivative of my function, which we got in part B. So therefore, I can now say 0 equals, with my in part B, we said this was 2 minus 2x plus y, and if I solve for y is going to equal, let's see, solve for y, we're going to get 2x minus 2. So what's m is 2, what's b? Negative 2. And there we go. How many points would this be worth? This is worth 3 points. Plus 3 points right there. Pretty easy. There's another way you can do this one, slightly harder, using systems of equations. This is, I think, a much easier way to do it. All right. Go on to next video. We'll take a look at question number 5. I'll see you then. Bye.